Building designers can achieve big reductions in embodied carbon. Join Corporate Responsibility Officer Amy Hattan as she talks with technical experts about ways to reduce the negative impact of buildings on climate change. Here's how Embodied Carbon is a production of Thornton Tomasetti.
Hi, and welcome to episode 2 of Here's How Embodied Carbon. This series explores how engineers and designers can reduce embodied carbon, which is the emissions from the manufacture, transportation, installation, maintenance, and disposal of building materials, and minimize the negative impacts of buildings and other structures on climate change. I'm Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer. We're an international, multidisciplinary engineering and consulting firm committed to channeling all of our capabilities to tackle climate change. And we've been focused on embodied carbon for over a decade. I'm talking with technical experts from across the company about the paths they are taking to achieve the greatest reductions in greenhouse gas emissions on their projects. Today, I'm talking with Michael Cropper, an associate principal and co-lead of Thornton Tomasetti's Embodied Carbon Community of Practice. He's going to talk about what structural designers who want to lower embodied carbon should keep in mind when selecting steel for their projects. Hi, Michael.
Hi, Amy. Where do you want to start?
Let's talk about steel. When we talk about embodied carbon, we hear a lot about concrete, but steel has a significant impact as well. Can you tell us about steel's carbon footprint?
Steel is one of the primary structural materials that we use in the building industry. So we have to understand the energy used in steel production if we want to use and procure steel sustainably. The steel and iron industry is responsible for 7 to 8% of global greenhouse gas emissions. In the U.S. alone, we produce 90 million tons of steel every year. And that's less than 5% of the global total. Most of the carbon footprint from using steel in buildings comes from the production process. The impacts of fabrication, transportation, and erection are fairly small by comparison.
Okay, that helps to pinpoint the problem. So, do we have options around the production process?
We do. There are two main ways that steel is manufactured. The first is the basic oxygen furnace, or BOF, process, which is used in about 70% of global steel production. It's also known as extractive steelmaking because it uses primarily raw materials. The second way is the electric arc furnace, or EAF, process. EAF uses up to 99% recycled steel, so it's known as circular steelmaking. It typically has just a third of the carbon footprint of steel produced with BOF.
Wow.
Now, aside from the inputs, raw versus recycled, there's another important difference between the two production methods. BOF uses on-site fossil fuel to generate the high temperatures that are required. But EAF uses electricity, which is more efficient, and it can come from renewable sources. So the electricity mix in a given region can affect the amount of embodied carbon in steel. That means that decarbonizing the electrical grid is critical to reducing the carbon footprint of steel production.
EAF sounds like the way to go. What should designers do to make sure that more EAF steel is used in their projects?
First, consider the shapes used. The mix of BOF and EAF steel varies by country. But in the U.S., 100% of hot-rolled wide flanges are produced using EAF. Plate and HSS shapes, on the other hand, are more likely to be produced using BOF. So keep that in mind as you're designing the steel structure.
Are there any other design strategies you can use to reduce embodied carbon?
It might seem obvious, but it's worth repeating. Reduce tonnage. Thorough analysis and careful design can cut the amount of steel needed in any given structure. And we can also look at steel grades and use higher strength steel to reduce tonnage.
I've heard it said that recycled content is the barometer for sourcing low-impact steel, but it sounds like it's not that simple.
It's not. When it comes to specifying steel, just specifying based on recycled content isn't enough. We need to move toward limits on total global warming potential. We need performance-based specifications that call for maximum global warming potentials for various steel products, similar to how we approach concrete materials. But since steel isn't quite as local a material as concrete, care is needed to specify realistic global warming potential limits. Ideally, we'd always be able to engage with the contractor early to learn what production facilities are likely to be used for sourcing so we can understand GWPs of their steel. Ultimately, there will be a combination of market forces and regulation that will drive wholesale reductions in the carbon emissions from steel production. Engineers can help drive the market side of that equation by engaging with the design team and advocating for lower carbon footprints in our steel structures.
So you're saying that we need people working on this challenge from many angles. Sign me up. Thank you, Michael, for sharing your expertise with us today. Folks, there's more. Follow Thornton Tomasetti for more episodes of Here's How Embodied Carbon.